Okay, we retain another integral. This one was sent to me by Sid. We have the integral of square root 1 minus x squared minus 2x times e arc sine of x dx. Okay, just looking at what we have here, this is a pretty suspicious looking expression considering, we have arc sine here in the exponent. We don't really want that. And the derivative is almost right here, but we want 1 over this. This 1 over square root of 1 minus x squared is just the derivative of arc sine. And another interesting thing is the derivative of 1 minus x squared is just minus 2x. But now the way we have it right here, a u substitution is not really going to work because like I said, this is in the numerator, we want it in the denominator. One thing I can do to rewrite this is if we have something just square root of a, we can always write this as a over square root of a. And then using that on this, that's going to allow me to bring the square root into the denominator. And then maybe this will be set up better for a u substitution. So what I'm going to do with this is let's rewrite this. We'll use this right here, but I'm also going to distribute in this e arc sine of x and split it into two terms. So using this on this here, we're going to have 1 minus x squared. Think of this to the 1 power. And this is going to be all over square root 1 minus x squared. And then distributing in this e arc sine of x, we'll have that here. And then for this second term, let me make a little bit of space. We're just going to have minus 2x e arc sine of x. But one thing I'm going to do, I'm just going to write it this way to show that we clearly have two terms that we're adding. And we'll write this as minus 2x e arc sine of x. Then writing it out this way, this whole thing is starting to look like the product rule. I'm going to want to try to break this up and put some labels on some things. So like, let's take this just e arc sine of x over here and we'll call this f. So for our f value, we have this e arc sine of x. And what I'm going to want to do is take a derivative of this. So when we do that, we get back the same thing. We're going to have e arc sine of x, but then we need the chain rule on this. Take the derivative of this, we get 1 over square root of 1 minus x squared. So then if we just kind of separate things out over here on this side, right, then what happens here, this right here is exactly our f prime. And then we still have these other terms left over. We'll try to deal with that. What I'm going to do is for this 1 minus x squared here, let's call this our g. So if g is 1 minus x squared, I'll take a derivative of this. For g prime, this just becomes minus 2x, but minus 2x is what we have right here. So this right here is going to be our g prime value. So now to put this all together and try to make sense of everything we found here, we just want to look at the product rule. So the product rule tells us if we have two functions in terms of x, f times g, and we take the derivative, it's just going to be f prime g plus f g prime. But now for f prime g, we have that right there. We define that. For f g prime, we have that right here. Now, all this stuff is inside of an integral, right? Well, if we integrate here, integrating this, we have the integral of a derivative. This is just going to give us back this for the result. So with this all being in this form here, we know our solution of this is going to be just f times g plus c. And we have this all set up where we know our f value, we know our g value. So putting it together, for our final solution of this, we're just going to have 1 minus x squared e arc sine of x, add a plus c, and that's it. Okay, there you have it. Another good integral from Sid. Thanks everyone for watching. Have a good day.